All right, and it looks like we are live right now. Hello, everybody. Welcome to Room 5. This is Postgres auto vacuum tuning lessons from the field. Uh, the presenter for the meeting today is going to be Jessica Sharp, and I'll go ahead and hand it over to her.
Cool. So, yep, like Justin said, this is Postgres auto vacuum tuning lessons that I have learned in the field. Those are always the most fun, I think. So before we get into it, though, we've got a couple of housekeeping items. If you've made it to Friday afternoon and still don't know where to leave feedback, it's in Loudswarm on the left, down to feedback page. It's a Google survey. Please do leave me feedback. I actually do read that. I actually do use it. It means a lot to me. I just ask that you be open and honest and clear about what I could have done better or what it was that you liked. One other kind of weird thing. If you see this icon on a slide, that means you may be interested in looking at this slide deck later, because on that slide in the speaker notes, there's maybe I worded things a little, I had a set way I wanted to word it, and it's sometimes when I get talking, I say things differently. So the important ones I made sure to put in the speaker's notes so you could go back later and read it. There are also some links to, further research on certain things that aren't necessarily totally relevant to auto vacuum tuning. So I didn't want to spend a whole lot of time talking about them, but I thought that they were important enough to at least link for you if you want to dig in a little deeper to a few things. For questions, we're going to use the same thing, the Slido. Justin's going to relay them to me at the end. If I say something that sounds totally crazy, or if there's something on the slide that you're just like, no, I need to know, like you're going to lose your thought by the end of the session, go ahead and we'll try and filter those through and pause and ask those as best we can. If you're watching this later, because this is going to be on YouTube, if you're watching this after October 23rd, yeah, it's the 23rd, use my contact information and just ask me questions directly. This is a slide. Here's the little notebook and the pencil. I have the link to the Utah Geek Events channel, YouTube channel in here. That's where this will be later if you want to just revisit it, or if you just want to revisit it. I don't know why my brain just tripped there. So if you have questions beyond that, what I would recommend doing in addition to your, maybe your usual places like Stack Overflow or Postgres documentation or the mailing lists. By the way, be careful about what you email out in the mailing list. That is public and it is people's inboxes, so be mindful. The Postgres community, if you don't already know, they have a Slack that you can request an invite to. That's the official Postgres development group, supports that. The PGUS group also has a Discord server that's not part of the official Postgres development group, but I think the Discord server hit 1,000 people fairly recently, and I'm in there, and it's a pretty active group. So either both, I'm in both, but I tend to ignore Slack a little bit more than Discord. I don't know why. It's just the way it is. These are great resources to use. Also great places to hang out and answer questions if you've got, lessons learned that are important to you. It's just not, because auto vacuum and vacuum is admittedly, it's something that even I struggle with. It's not, it can be very difficult when things start going wrong. So if you still need help and support, not to make a total joke of the consultant role, but I am available. If you look me up, I'm very much attached to Enterprise DB. I'm working through cleaning up those references and kind of breaking those links. I'm actually an independent consultant now, split fairly recently. So if you need help and there's something that I specifically can help you with, the good news is you do not have to go through the enterprise DB sales team anymore. You just have to deal with me, although that may be worse, I don't know. But point is, I'm available to help and we can talk, just don't touch my stapler. All right, so who should be paying attention to this? And we'll talk about the reasons about why this is actually important and why this is going to be particularly a waste of time if this presentation isn't for you, maybe a headache for no reason. But if you're a DBA, you're in the right place. If you're new to Postgres and you're a DBA, you're probably in the right place. I've done my best to break things down in as simple a way as possible. But like I said, with Autovacuum, that is an intermediate and an advanced topic. So either have a Postgres friend or yeah, I would recommend just having a friend. So also, if your database has a lot of transactions, especially if they're all happening within short periods of time, or repeatedly over long periods of time, and it's just a massive amount of transactions. More so if you're mission critical and you've got a standby or multiple standby databases, and these are large databases with a lot of transactions, and you need to be able to fail over with zero data loss, instantly. If you've got a problem and your Autovacuum needs to be tuned and that other criteria fits you, you really need to be paying attention, because Autovacuum, I've seen, and I don't want to call them issues, but I really can't find another word. If you've got issues going on that would indicate that your Autovacuum needs to be tuned, you're most likely, I cannot tell you how many times I've seen this, you're most likely also having issues with replication lag and excessive write-ahead log generation. And we'll talk about how do I know if it's excessive. Replication lag is pretty easy to tell, is it out of sync? More than a couple of seconds for some is absolutely unacceptable. Some I've seen they're 2 and 3 hours out of sync and they're fine. So it just depends on your business needs. But also the other kind of giveaway to where that would indicate if you need your you need to touch your Autovacuum parameters. If you've got a query, let's say you've got a query or a group of queries on Monday, runs in about 10 minutes. Maybe that's not great, but it's a big query, it's doing a lot. Tuesday, it takes an hour. Wednesday takes 4 hours. And by Friday, maybe you're up to 12 hours on this query. And then Monday comes around again. Oh, what the heck? And it's 10 minutes again. Yep, you need to tune your Autovacuum. And I know those numbers sound crazy, but I've actually seen that. So don't underestimate erratic query performance. So this probably isn't a complete list, but these were the big ones that stood out to me that this presentation might be helpful for. Who this is not going to be helpful for is application developers. If your DBA or your team has gone through at this level, at the infrastructure level, and tuned the heck out of the database, and your system administrator, they've worked together and they've tuned the OS. I've seen some cases where that was needed as well. And you're just like, okay, or at our rope, the end of the rope here, and we're still not seeing an improvement. You may want to look at code changes or database design changes. And sensitive topic, but I'm the queen of broaching those. if you can start with design changes, especially in code changes, you really should. I'm not going to go as far as to suggest the DBAs push for that before they take the more traditional approach of just tuning the database, because I understand the pressure and I understand a lot. I want to say probably 98% of projects I've had over the past 10-ish years, code changes were just out of the question, especially if you're on a timeline and, you know, especially if you're a consultant and you're only there for like 2 months or some, you know, that was an oddly specific number, I'm sorry. But it is worth discussing, and if it is at all possible, makes life a lot easier. That doesn't mean don't tune the database, but it's going to make a big difference. Also, this presentation is not for you if you're on 9.5. And, you need to upgrade. You need to upgrade. And I understand that it is hard to want to, or to be able to justify, especially in not lower environments, an upgrade if your database is unstable, and many which need auto vacuum tuning are unstable. So this is a little controversial advice, but please, please, please upgrade. There are so many pieces that just don't exist, so many tools that don't exist in 9.5, and that would take me it's not relevant enough for most of us for me to dive into. Just be aware. If you're maybe not on 9.5, but if you're just curious, I thought I would mention this. I typically find that people aren't necessarily aware. On the Postgres, in the documentation on their website, they do have trying not to call it a support matrix, but it is kind of a support matrix. And there's a little bit of an explanation about how the version cycle, the major version cycle for 5 years, and then there's one more release, and then the development group stops supporting them. Those dates and the map, you know, the corresponding version are all on the website. So I have that link in the speaker's notes on this one. All right. Who is this crazy lady over here talking about auto vacuum is hard and stuff? Jessica Sharp. I do Postgres. I also do Oracle. So most of my projects, especially the past 2 years, because I have a background with Oracle as well, a lot of what I do is helping groups and environments that are new-ish or brand new to Postgres, and they just migrated off of Oracle. If it wasn't me that migrated off of Oracle, then this is where I come in and I say, okay, we need to tune correctly. Things work differently than they did in Oracle. Here's what works differently, things like that. So with that being said, we're just going to level set here and make sure that we're all on the same page. A big difference that when I'm talking to people new to Postgres is concurrency control. That's a big topic. There's some weird myths and rumors on Postgres, I suppose, but so Postgres uses multi-version concurrency control, and for me, getting my head around this, I don't know why, because now that it makes sense, it's kind of like, well, it makes sense. But for a while, I struggled because I thought, okay, so if multi-version, so you have multiple versions of the database, but then how does all this fit together? And I was jumping in too deep, too fast, and that's why I'm slowing it down for this, so we can break it down and think through it. A lot of the documentation and a lot of blogs and whatnot on vacuum and auto vacuum, they talk about cleaning dead tuples. I always say that wrong. And this is where my head started to spin a little bit. I go, okay, so a row is dead and we're cleaning the row. And in my mind, for some reason, I thought we're deleting the row or the old row. And that's not what Autovacuum or vacuum does. We'll get into that. What it does, what the way that this works, and why this is important for Autovacuum, or understanding this is important for understanding Autovacuum, is, so let's say I've got one row of information that I've inserted. Now another user comes along as another session and says, you know what, actually, we need to update this column on that same row. And another user comes in and says, you know what, we need to actually change this other column now too. What multi-version means is that you've got multiple, you do have multiple copies of that row. It never goes back and wipes out the data from that column in that original row. That's not how it works. What it does is it puts it in, it decides what the change would be, what the end result would look like, puts it in as another row, and then it marks your, it puts a flag on there. It says, okay, well, this is the most recently changed. This was changed in this session. Here's the ID on that. And it's kind of like it kind of tells you at what point in time. So the original row is now flagged as no longer visible. It's still there. It's just not visible to users, the DBA included. In a nutshell, the multi-version concurrency control, if we're just talking database theory for a second here, this is what Postgres uses for transaction isolation, which the multi-version, you know, each transaction is isolated and doesn't see another, sorry, not transaction. Yeah, transaction is isolated. So each session, each user doesn't see a different version than they're supposed to. This also means that locks for reads don't block locks for writes. Tongue twister. So reads don't block writes, writes don't block reads. Very oversimplified version, but that's, we're going to leave it at that for now. So a common question I get about this, and it was, in all fairness, one of my first questions when I thought through MVCC too, was, okay, so if Postgres is storing multiple versions of itself, doesn't this mean that I need a lot more disk space for my database than I did in, I don't know, Oracle? And the short answer is no. Long version is this is what you have the auto vacuum and the vacuum for. But the follow-up discussion around that is also, it can be a problem if there's heavy database bloat, which means rows that are not active, that's bloat. Then yeah, your database is going to take up a lot more space. If you're not vacuuming enough, that could be a problem. That could, you know, that's going to be a big hit on your database later, but probably not in terms of disk space. Maybe, probably not. I haven't seen that a whole lot of times. It also means there's less data found in the cache if your auto vacuum is not running efficiently, which maybe I'm pointing out the obvious here, but you know, you want to fully utilize your cache as best as you can. So enter auto vacuum, which is why MVCC works in Postgres. I just like this XKCD. I have to slow down every time I say that. They're comic. First time I saw this, I remember my very first like real auto vacuum tuning project. This was how I felt. I felt like, whoa, the database has superpowers now. This is awesome. But it's not magic, and it's maybe it's a superpower. We'll leave that one alone. So I mentioned that everywhere that I was looking online referred to auto vacuum as you know, it's there to clean up dead tuples, which is a row, if that word is weird to you. I interpreted that as kind of, okay, so over time, the database collects garbage in terms of these frozen or these old rows that aren't the visible version of themselves anymore. So vacuum and auto vacuum, well, auto vacuum is kind of like the garbage service. You know, you put your trash out like once a week, and then they come and take it, which ironically enough, I actually don't have garbage service. I actually have to walk mine down to a dumpster. So in my personal life, going with that analogy, I don't have an auto vacuum, I have a vacuum. In which important distinction, auto vacuum does not, now locks do happen, but they're not a direct result of the auto vacuum process. I have heard that a few times. I've had customers want me to kill the auto vacuum because they swore to me that it was causing a full table lock. And I said, no. It has been an interesting few times proving the difference between auto vacuum, which is not just vacuum, but vacuum isn't going to do a full table lock either. Now, if you do vacuum full, which is something you have to manually kick off unless you've scheduled it in something like cron or something, then it's kind of auto, but it's still vacuum. Auto vacuum is the Postgres one that kicks off automatically and thinks it's smart enough to go. And usually it is smart enough, but so, okay, so that makes vacuum full sound really bad. And often it is. If you're in a production environment, you have a 10 terabyte database that has these transactions going. You probably can't afford to take a whole table at a time, especially if there are 500 gigs. And that maybe doesn't sound big, but for auto vacuum, that is. And we'll talk about why. But you can't do you can't do a lock on the whole table. That's ridiculous. That's an outage you can't take. Thankfully, auto vacuum, the biggest use case that I've seen for it is reclaiming disk space. It will actually reclaim disk space. The other ones won't. They'll mark the old frozen rows as irrelevant, and it'll also mark those rows as okay to write a new row to that same space. Get that question a lot too. Okay, so how does that work? So you've got files. The files are in 1 gigabyte chunks, so each file is 1 gigabyte. Please don't ask if you can change that. Please don't. In each file, you've got 8K blocks. Simple enough, right? Okay. Now we want to start thinking about buffer cache. This is going to matter. This is where the memory part comes in. So we're going to read something in a file from a block. We have to go to disk. We're going to pull it to buffer cache, work with it there, put it back, whatever. So that's how that works. This feels a little out of place in the presentation, but understanding this is going to help you on your later calculations, and you're going to understand why the numbers that you're getting are the numbers that you're getting for, well, we'll get to it. So, okay, so we mentioned that the vacuum and auto vacuum don't just remove the rows, it saves the place, and it says, hey, we can use this again. How does it keep track? That's going to be the free space map. What it does is it sends that information back to the free space map, which is why when you get into trying to measure, you're okay for measuring wall space, but not much else than that. Check your free space map, not necessarily disk space, but just keep this in mind. Okay, so we're all ready to go. Now we want to start looking at this. We need, because Autovacuum is hurting. We've got queries that are going slow. Slow down. Slow down. You've got to monitor. You've got to set up monitoring. You can use maybe a combination of these things. Well, you're absolutely going to use extensions. I've had to use just queries before. Second Quadrant has some really great monitoring specific to the things that you need to monitor around Autovacuum. They've got great queries on their website. I'm going to have some queries. I'm rewriting quite a few to cover the different versions. If you're on 9.5, you're going to be heavily interested in a set of monitoring queries. I'm going to leave it at that. I'm going to put that on my GitHub. I think if you just search Jessica Sharp, it should come up. Monitoring tools are very helpful. You could use the extensions and custom queries to set up your own custom monitoring tool like Grafana, but if you can use anything else, I would. You just need something. All right, so what do you monitor? You need live when you're expecting to have problems, if you've gotten this far and if you know this much. You want to monitor your currently running Autovacuum processes, and you will want to kind of document what process, not what processes, you'll want to document which processes are running on which tables and indexes over time, because trending that data might sound like an extra chore, but it's helpful, I promise. You will also want to monitor the trends for how many Autovacuum threads are in use when certain tables are being monitored, You want to know your max Autovacuums. By the way, on most servers, on most databases, I say try not to push it above 5. Really, you need to tune if you're going above 5. That being said, I've seen some not be able to get by on 5. I've seen a few up at 8 max Autovacuums, and I've seen that really come in handy. I've seen, you're monitoring the session, the processes, and all of a sudden there are 8 Autovacuums running to prevent wraparound. So you also want to keep an eye on disk writes and the efficiency of those disk writes. And this goes back to when we were looking at our files, blocks, and memories slides. If your disk writes are high, and okay, how do I know if it's high, Jessica? Well, if your buffer cache is being underutilized and it's big enough and you've gone through buffer cache tuning exercises, which different presentation, then that can be a red flag for you. You'll also want to keep track of the last Autovacuum time per table. This comes in handy when you've got certain tables that are getting auto-vacuumed every day or all the time and they don't stop, or it's 3 or 4 times a day. You can kind of plot out the trends of, okay, when was it running on this table? You'll also want to, and this is not a dynamic thing to monitor, but you will want to know what all of your configuration parameters are and are set to that are relevant or impactful to Autovacuum or vacuum in any way. I talked about disk IO time, sorry. You also want to monitor CPU usage. When I say that, and I'm laughing because I've seen people do this, again, sounds obvious. I do mean CPU usage at the time your Autovacuum is running during that window. If you're all fine and dandy, you don't have any queries really that are running out of their usual state, CPU usage isn't going to do you any good. So don't do that. Historical data that can help you out, maybe not so critical, but well, some of this is. How long did the Autovacuum run on each table? This isn't, sounds like a small thing. It's important. This can very quickly alert you, okay, we need to look at this. I saw, we had a few instances where we had like a problematic 4 or 5, I think it was 4 tables, all between 300 and 600 gigabytes in a multi-terabyte database, and Autovacuum, and we couldn't get, it was a struggle to get the customer to focus on the Autovacuum tuning, and there weren't enough of us. We had too much going on. So we got pulled into other things, and this kind of just kept going on for embarrassingly long time. We were noticing when looking back, Autovacuum was running on our big tables for maybe 3 or 4 hours at first, and we were noticing an impact on the database, not because of Autovacuum, that's an important distinction, but because it was at its max, the database was just, yeah, anyways. And then we'd look, and the next day, you know, same time, same day, it would be like an hour or 2 longer. And then the next day, it would be like 10 or 12 hours. And we're going, yeah, okay, something is wrong. So it's a really fast way to get a bird's eye view of, yeah, we need to look at this. You also want to know how many times it ran per table, especially on those tables where it's starting to run longer and longer and longer, or just in general longer than you think it should. This is also really quick, like, okay, something is wrong. You also want to monitor your frozen tuple age. You want to plot that out and keep track of that over time. Excuse me. And your XID consumption, XID, if you Google Autovacuum tuning, you're going to see XID everywhere. I might as well explain it. If you don't know, that's just your transaction ID. So the transaction IDs, when we're talking about multi-version concurrency control, if I can say that without tripping on my words, a while ago I mentioned that there's a flag in there. There's a flag that says, yes, this is visible. There's a flag that says, add this to the free space map. And then there are 2 sets of IDs. And one of those IDs says, yes, this is visible to the user. And the other one says, no, but it's not a binary. It's not a true or false. It's a number, and this number increments. So there are limits to all great technology. It can only increment so many times. So you can only update not a row, but the space for a row that's been written a finite number of times. Don't ignore that fact. See, people ignore that fact too. You might think, I'll never reach the limit on that. I'm not updating. You need to keep an eye on that, because yeah, you might take a long time, but it also might not. I've seen it get hit in as few as 10 months. And what happens if you don't go back and free that and say, yes, we can reuse that, which is what the vacuum does, and you hit that limit, your database crashes. And you might want to go complaining to the development team and say, hey, don't crash the database, you know, because it's an intentional crash. Just don't crash the database. Let me just keep going. Just let me keep going. Not a good idea. Don't just vacuum, just auto vacuum. The other thing that you do want to monitor is your long-running transactions. Now, I know I said that for auto vacuum, it's not a full vacuum, doesn't reclaim space, and it doesn't put a lock on the whole table, so you can still do queries against the table. But you may have some resource contention going on there, and I'm not saying that there are no locks. You may hit locks, but it's not a an auto vacuum lock. It's a lock as the result of the auto vacuum's activities, and the possible, with your transaction isolation, you've got a few complicated things that if auto vacuum is taking forever to run, your risk of having a transaction run a bit longer than usual is high, as it is if you don't auto vacuum aggressively enough. So, what it's doing there is your query is not just looking at right off the bat. It's not looking at the ones marked as visible to the user. It has to sort through everything in the table, and the database has to go in and it has to say, okay, so out of all these rows, we've looked through all these rows, but now there's this added step of I have to remove certain rows for the user because that row shouldn't be visible to this user in this session. That's what's going on behind the scenes. Not a whole lot you can do. The urge to kill the auto vacuum process gets strong sometimes. Don't do it. It's not helpful to anybody. Let the auto vacuum finish. I know it's painful to watch sometimes. Preventative maintenance is the best medicine here. It sucks, it's painful, I know, I'm sorry. So, got the monitoring stuff out of the way. Now I get to the cool stuff. So, before we talk about controlling IO impact, we need to understand IO points. Points, not in the there's no technical definition here, it's just there is a point system that the vacuum and auto vacuum use. So each of these three things cost points. Just hang on to that for a second. Vacuum and everything here, I put vacuum, but there are duplicates of these that say auto vacuum, so you can tune them separately. But auto vacuum will default to the vacuum parameters. But if you wanted to tune them separately, you could. So the vacuum cost page hit, which is the cost of vacuuming a buffer that was in buffer cache. You want to do this. You want to be able. You're going to be able to use your buffer cache a little more efficiently. So this isn't a bad thing. The vacuum cost page miss. This is cost of vacuuming a buffer that was in buffer cache. Multi versions here, so keep this. That's why it's weird. Threw me off until I was like, oh yeah, I'm BCC. Vacuum cost page dirty. The cost of modifying. Oh, sorry, I thought I made a typo. A buffer that was in the buffer cache. So this is not the cost of vacuuming it. This is the cost of like if vacuum or auto vacuum analyzes it and it says, okay, I don't need to modify this buffer that was in the buffer cache, then you only have your page miss. If you have a page dirty, then it says, yeah, I actually need to modify this and vacuum it. So these are your defaults. I've never adjusted those. I'm not saying don't. I'm just saying I'm not sure if it's maybe it is, maybe it's not. I'm personally not sure that it's entirely worth the effort. These are not the low-hanging fruit things, is what I'm trying to say. Anything where these would be helpful to adjust is going to be a significantly advanced topic. So, and I'm over here, and I said I wasn't going to run out of time. Yeah, we're good. Okay, so now we understand IO points, or we at least know what things trigger IO points. So your auto vacuum cost limit, these are the two parameters that are big ones around your IO impact to control that, to modify that. Auto vacuum cost limit, this is a global setting for all of your auto vacuum processes. You cannot set a cost limit per auto vacuum process. It's for all of them. And what this is this is the point, the IO points, the total IO points that you're allowed to do before the auto vacuum delay period kicks in. So, and I messed this up, this slide. The auto vacuum cost delay is not, in fact, there's always this one stupid thing on the slide. The cost delay is not, in fact, how long before the auto vacuum will strike again. What determines the period that auto vacuum waits before it kicks in on the table again is actually the nap time. The cost delay, let's put it this way. So if you have reason to be concerned, and I always, especially if you can, do your homework, prove it before you adjust this. This is how much to throttle the auto vacuum. So if you're concerned about resources and you know that auto vacuum is hogging your machine resources, or there's an issue with other database resources, then you would maybe increase the cost delay. In general, you want this to be very low. And again, the auto vacuum and vacuum, they're just separate parameters for each, so you can tune independently. All right, so for memory, the big ones are the maintenance work mem. This is how much memory can the auto vacuum use, but this is also inclusive of all maintenance operations beyond the vacuum and the auto vacuum. So this isn't just vacuum. So if you've got other maintenance operations going on while your auto vacuum is running, there is going to be contention. They're both sharing the maintenance work mem pool. Now the auto vacuum work mem parameter, by default, I think in all the versions, I think it's always been this way. It defaults to your maintenance work mem value. But this is specific to auto vacuum. So this is helpful if you know you've got a certain percentage of your total available memory that your maintenance, maybe you want to say max peak because I don't know, and you don't want auto vacuum to interfere with that, you would cap it using the auto vacuum work mem. That's really the only time I would set that. So we've got IO impact, can control that. We can adjust the auto vacuum work mem. Something that affects this, I said that backwards. Other parameters here that you'll want to watch out for and can look at, but maybe aren't directly related to memory, but you should also be looking at, is your max auto vacuum processes. Like I said, like if it's set to like 1 or 2 and you need 5, that's where you would do that. But keep in mind that you are going to use up more maintenance work mem with that. So you need to calculate that and adjust your maintenance work mem accordingly, as well as make sure you actually have enough memory on the server. You may need to upgrade your hardware. Hardware doesn't solve a software problem, but sometimes you just need more memory. So brain spazzed here. Oh yeah, okay. So the other kind of big thing you can control here and kind of adjust is your row freezing trade-offs. And the reason I'm saying it's a trade-off is because, let me explain this first. So your auto vacuum freeze minimum age is one of the parameters that you'll want to look at. The default on this is 2 million. And what this says is how long does this transaction ID how old does it have to be, sorry, not how long, how old does it have to be before we freeze it so that we can reuse it. The space, that space in the block on the file. When, I'll save that thought. Default is 2 million. For most, that's fine. I included the note, said the limit here is 1 billion. Do not start at 1 billion and go backwards. Just don't do it. You want to be, about, because you're trying to predict where you are. If you've got a circle, like a cycle for your transaction IDs, you want to predict what's ahead of you at what, at what given point in time, what is going to be ahead of you and how much is behind you, because you want to be about 50% ahead of yourself. You probably could get very more mathematical about it, very advanced. If you don't like math, just get a friend to do this, and your friend is going to hate you and probably not want to be your friend anymore, but that's right, hire a consultant, I guess. So if you say, no, I don't want to be 50% ahead of where, around the cycle before I mark it and reuse that spot, I want to be 70% ahead. Well, okay, fine. Fine. I can't really actually think of a really good reason other than that's just annoying, but you don't want to go the other way and say, no, it's too expensive. I'm only going to, we only want to be able to reuse after 20% ahead of where I'm at. Then you're probably going to crash and burn because you're probably not ahead of yourself enough. It's like you have a big meeting, we're working remotely, and your meeting is scheduled at 5 a.m. because time zones. True story, this has happened all the time. And I need to share content in that meeting. Am I going to wait until 11 p.m. the night before to put together my content for that meeting? I'm not saying I've never done that, but I'm saying that's a similar concept here. You don't want to do that. You want to give yourself ample time. Do I want to do it too early, like a month ahead of time? No, because then I'm going to forget everything. So I'm not saying you're going to forget everything in your database. I'm just, bad example here. So more on the topic of row freezing. That's why this is a trade-off. There's like a kind of a gotcha about every single one of these 4 that I'm going to share. The Autovacuum freeze table age. This, I don't want to call it a best practice. I don't believe in best practices, but an okay starting point is to keep the freeze table age at about 80 to 90% of the max freeze age. This is specific to your tables, so it looks at some different statistics in the database. Similar concept, it's just specific to a table. This is more relevant if you're auto vacuuming on a list of tables instead of saying, yeah, just auto vacuum everything. Please don't do that, but you can. This threshold, though, is also how old can the oldest transaction ID be before we trigger an aggressive vacuum. This is where you need to watch your CPU usage, because an aggressive vacuum, what that's going to do is the vacuum, or the auto vacuum in most cases, it's going to look at every block in every page in that file. That costs server resources. Like that's a heavy, you're going to max out you may not max out, but you're going to see some increase, and it I don't want to discourage it, but if you're not needing an aggressive vacuum, if it's just a regular kind of conservative, it won't read every single one. It'll only look at ones that are specifically marked. Like if it can tell that this hasn't been updated, it's going to skip over it. This will not, it will hit every single block, whether it thinks it needs to or not, because it's going to make sure. So you may want to look at maybe not 90%, maybe go with 80% of your max freeze age overall if you need to get more server resources. If you need more memory on your server, because I don't want to discourage an aggressive vacuum. They're very much needed. It's a good idea, but also sometimes in a pinch, and it's going to hurt you in the moment. But you know, so what? And I broke my thing. Hang on. Okay, I did something. I forgot a slide somewhere or something. Great, 2 mistakes. So the auto vacuum freeze max age. I have a typo on a couple of these slides. I am sorry. So this says 80 to 90% of auto vacuum max freeze age. It should say min. Apologies. This is extra slide. Max freeze age. So 1 billion or higher. This is where that circle comes back into play. So this behind the scenes, there's a silent limit to the min age. It'll kind of force it to say, no, we're half of the max age. But same concept applies. All right, so practical applications here. How do I know if a table needs to be vacuumed? Is auto vacuum vacuuming correctly? This is the formula, and we're close on time, but I think I can get through. So the threshold is, and this is straight, this is a comment from the code. This is not the easiest thing to follow, but your base threshold plus your scale factor, which is usually 0.2 or 20%, times your total number of rows. So if I have 100 rows, scale factor is rows changed, sorry. So if I have 100 rows and my base threshold is, I'll say like 5, then I'm going to add that to my scale factor times my time. So multiply scale factor and total rows first. So we're going to say 20% of 100 is 20 plus my base threshold, we'll say 5. So 25. That's how Autovacuum knows. 25 rows have changed, turn on. So let's say I change 18 rows, it's not going to turn on. Change 50 rows, yeah, Autovacuum is going to go. So if you want to play with those, if you want to be more aggressive, decrease your scale factor, which sometimes is necessary. 20% doesn't sound like a lot, but when you're in the millions of rows, it actually is. It makes a difference. So ideally, though, like I said, like usually there's database design that can massively help relieve this if it's an ongoing problem. I understand a lot of times it's too late and a lot of times it's not an option. So at that point, you just say, okay, well, do the best we can everywhere else. When you're tuning, you need to sit down and decide how much bloat can I tolerate. Your bloat level is never going to be 0. That's not how Postgres works. Healthy database is going to have a little bit of bloat. So this is a business needs thing. This is a risk model, kind of an exercise in determining risk. It's also an exercise in, and I'll talk about this a little bit more in like a minute or so, but I've seen a lot of, really bad blow issues, and it causes this auto vacuum will have to work harder, which firsthand experience in the older versions of Postgres. Your wall generation goes up because of those, because it's an aggressive vacuum and it has to look at every single block. So everything, your wall kind of explodes and you're like, what the heck? So if you're streaming that or shipping that, may the force be with you, you're going to have replication lag. So what do? You be more aggressive with the auto vacuum by raising the cost limit so that there's less of a throttle on the auto vacuum. Lower the cost delay, lower the nap time too. The nap time I think is by default like a minute. If you're tuning auto vacuum and you leave your nap time at a minute and you've justified tuning other things, you missed something. Decrease the nap time heavily, like under a second in your larger databases, and lower your scale factor so that your watermark for needing, triggering an auto vacuum is lower. So it goes sooner. Also, a note, it could be a whole presentation on its own, and I'll spare you. Be careful when you're adding new indexes. Look at the ones you've got. Make sure those are getting vacuumed too. Take advantage of your maintenance windows. Your maintenance windows, if so, auto vacuum, the truth of it is, like, it's powerful, it's cool, it makes you feel like a superhero when it works, but sometimes you need to manually vacuum. So strategically take advantage of your maintenance windows if you have them. At least be aware of what they are to know if that's an option, and do manual vacuuming during those maintenance windows. Table partitioning can help. Make sure if you're going to, you take advantage and implement table partitioning if this is new for your ecosystem, for this database. Look at your code, look at the code. And again, that's a whole other presentation. Just be aware that you need to look at the code if you're going to add partitioning in hopes that it'll help the auto vacuum. I cannot tell you how many times I've seen people go in and add table partitioning or migrate from Oracle to Postgres onto table partitioning, and they didn't change the code, and it's not pretty. It's not pretty. You think you're doing your database a favor, and it can really backfire. So again, look at your code, especially if you're partitioning, but also just if you can look at the code, just look at the code. Try and change it. I had a story here about excessive wall generation causing replication lag, and the customer was not letting the team focus on the auto vacuum tuning, which was closer to the root problems of the overall database issues that were going on. We had to focus on the excessive wall generation because it was causing replication delay upwards of 12 hours sometimes. So it's okay. It's okay to let the auto vacuum tuning go sometimes momentarily to, in that example, it was upwards of 12 hours. Really needed to rebuild the standby, really needed to focus the energy on that and come back to the tuning later. It's perfectly okay to do that. And I'm not going to share more of that story because we really are out of time. On that note, please do follow-up questions because, like I said, like tuning, it's hard to cover this in an hour and hit everything. There's so much involved and there's so much that could be looked at. It's also not easy to absorb. So if you think of something later, reach out to me. I am also in the Slack here, so reach out to me here too. Although I tend to ignore Slack and it is Friday afternoon, so might not be fast, but I will answer. You can also email me or find me on Twitter at the Sharp DBA. Way too available on Twitter. So really, if you have a question, just shoot me a message on Twitter. Are there any questions that I can answer right now?
I am not seeing any, Jessica, and I think we are moving on to the final meeting, so we can go ahead and close out.
Cool. Well, I hope that was helpful.
I know I learned something.
Good.
All right.
Not just that I've got a headache from excessive wall generation.
That too.
Right.
High-powered vacuums all day, every day. I liked that comic from at the beginning. That was a lot of fun.
Yeah.
All right. Well, thanks a lot.